friends, again we are come with a new video where we are going to discuss about the law of gaseous volume. Gas, as we all know, it is totally free. It has a lot of free space in it, that is void. Gas can travel anywhere. Gas has density. Gas has its own density where the molecules move there. So what is the law there? When gases combine, they do so in volumes. When gases combine, they do so in volumes. They do so in volumes which bear a simple ratio. When gases combines, they do so in volumes which bear a simple ratio to each other. Which bear a simple ratio to each other. Which bear a simple ratio to each other. And also to the product. And also to the product. And also to the product form. And also to the product form. And also to the product form. I can illustrate here this with a simple example. For example, I can say if I am going to do a question. Here let us do the formation of water. If I have to do formation of water, basically I have to take what? I have to take hydrogen and I have to take oxygen, right? Here I have to form what? I have to form water. So according to this law, if I have to form water, just now what I have written, that both the elements reacting on when the gases combine, they do so in volumes. Just now I have written as volumes, which bear a simple ratio to each other, and also the product to it. So first it is said to be, it is measured in volumes, so let I can give it as grams. Now it is in grams, plus I can say it is in grams or it is in ml, but before that I can tell you it is a gas. So simple whole number ratio. If I show you, here it is twice of hydrogen, here it is single. So if I write here as half, because hydrogen never remains alone, it needs at least two molecules. So H2. And O should be single, but O also never remains single. So here it is also O2. But here what we need? A single O. So if you can see, now before it was like this. Hydrogen of molecule plus oxygen molecule in the form of gas. Two gaseous molecule will come out, but we should get water. But in order to make it simple whole number ratio, that is, it is 2:1 or 1:2. So what we write here is half. If I can show you this half, this 2 and 2 will cut. Near means there is single. So this is how it is balanced. So one molecule of hydrogen here combines with half volume of oxygen to give one volume of water vapor. One volume of hydrogen molecule combines with half volume of oxygen molecule to give one volume of water molecule. This is how law of ratio volume. Similarly, if I say this was the formation of A, I can say formation of ammonia. Ammonia is seen like this. NH3. So if I want to form NH3, I should what have? I should have nitrogen and hydrogen. So here I could write nitrogen molecule N2 plus again hydrogen molecule H2. But I have to form NH3. So how I am going to form NH3? If I have to form NH3, then how I am going to form it? Since I need 3 hydrogens, so how I am going to do it? So here I can do something. Since here it contains also 2, but here it is 1. So here it is again into. So what I do, I give it 2 here in order to balance nitrogen. So if I write 2 here, 2 and it is clear, but it becomes 6. 3 into 2, 6. So what we do, we write here is 3. So this is how we balance it, and here I can say 1 volume of nitrogen combines with 3 volume of hydrogen to give 2 volumes of ammonia. Right? 1 volume of nitrogen reacts with 3 volumes of hydrogen to give 2 volumes of ammonia. Similarly, here what we do, here we will do a question. A question related to this law. 8 liters of hydrogen molecule combines with 6 liters of chlorine. 8 liters of hydrogen molecule combines with 6 liters of chlorine molecule, which gives us 2HCl. 8 liters of hydrogen molecule combines with 6 liters of chlorine are allowed to react at possible extent. Find out the final volume of the reaction mixture. Suppose that pressure and temperature remains constant throughout the reaction. So here what it is written, yes, if we go for equal volume, so before the reaction it is 8 liter and 6 liter, but after the reaction, can you tell me what it becomes if you balance it? Here I can say that 8 liters of hydrogen is combined with 6 liters of hydrogen, this is 0 before reaction. But after reaction, before reaction, but after reaction, here it is 6, but here it is 2 liters are left because equal volumes are used. 6 is used, and here also 6 is used. So 2 liters are left. After the reaction, chlorine left is 0. And in what it becomes? It becomes 12. 6 plus 6, it becomes 12. So what happens to the total volume? Because they have asked, find out the total volume of the reaction mixture. So can you tell me what is the total volume? So the total volume is amount of hydrogen left plus reaction mixture. Reaction mixture means this and this. Amount of hydrogen left and HCl formed. So it is 2 plus 14, 2 plus 12, that is 14 liters. It is total 14 liters. that is amount of hydrogen left and HCl formed. This question also came in the year 2001. In UPSC. It was given by a scientist named, very famous, JEET. I don't know the exact year, but according to me it is 1808. 1808. 1808. Yes, I remember it. It is about 1808. So one last law to be remembered, that is you write as Avogadro's law. It is Avogadro's law. It is Avogadro's law. Avogadro's law of equal volume of gases. Avogadro's law, equal volume of gases combines with equal volume of gases under similar conditions of pressure and temperature possess equal number of molecules. Equal number of gases under similar condition, equal volume of gases under similar conditions of pressure and temperature, equal volume of gases under similar conditions of pressure and temperature possess equal number of moles or molecules. Possess equal number of moles or molecules. That is simply as V is equal to L or V is equal to capital N. Equal number of moles or equal number of molecules at constant pressure and temperature. This law is followed or given by Avogadro, that is Avogadro's law. And earlier, the next video, that is very important video, is coming on to be on mole fraction. Mole fraction and mole concept, where we are going to discuss about the mole concept, how we are going to deal with it, mole concept and other problems.